Now, spoofing attack mitigation. So because there are many ways to implement a spoofing attack, it means we have various, let's say, tools or mitigations available against that attack. One commonly used one is going to be access control lists, and in that particular use case, we can make use of either RFC 2827 or RFC 1918. Now, RFC 2827 is going to define a list of IP addresses which have not been allocated or have been allocated with specific purposes, which means that you should not see traffic, you should not allow traffic from the internet coming with those specific source IP addresses. Likewise, RFC 1918 defines a range of IP addresses which are called private, which should be used within the private side of the network and which are not routable in the internet. So likewise, there should be no traffic in the internet sourced with IP addresses in those ranges. So what this means is that you would go on the edge of your network, which is like in here, to the edge of the network, facing both the LAN and the internet. And inbound from the internet, you're going to perform source filtering. You're going to do IP filtering on the source based on both RFC 2827 and RFC 1918. So this makes sure that you're not going to allow incoming packets in your network if the source is either private, as in RFC 1918, or which is not routable as well, or if the source is not allocated, or it has a specific use case and it should not see IP traffic with that specific source. Unicast reverse path forwarding, which means that you're going to go ahead and on specific network edge devices, you're going to configure URPF so that a network device is going to, when it receives a packet, in order to accept it, is going to do a route lookup against the source and see if he's going to drop the packet or not based on how the source is being reachable. Like for example, let's take the firewall. And of course URPF has different implementations. Let's speak about one of those. If from the firewall point of view, test server A, which is 111.1, is routable in this direction. So if from the firewall point of view, 111 is reachable in that direction, then if you configure URPF in strict mode, let's say, on the firewall, URPF, which means unicast reverse path forwarding check in strict mode, if you implement that on the firewall, then if that firewall receives an IP packet from this direction with a source of 1111, then the firewall is going to drop that packet, because from the firewall point of view, that source is reachable via another direction, not via that direction. That's why it's being called unicast reverse path forwarding check. So when this feature is implemented in strict mode on a networking device, when a networking device receives an IP packet, it looks at the source of the packet, and if the source of and then it looks in the routing table, that's a IP route for the source. And if the interface the packet was received on is not the same as the interface that device will route packets for that destination, then it's going to drop the packet, because it means that the source has been spoofed. Then we have other tools which we're going to speak about in the upcoming days. Like against ARP attacks, we have ARP inspection or dynamic ARP inspection. Against DHCP, we have DHCP snooping. Against IP spoofing from the inside, we have what is called IP source guard. Against routing protocol attacks, so spoofing the source to end up with routing protocol attacks, we have routing protocol authentication. We have BGP TTL security. Likewise, from the routing protocol point of view, IP options checking, which defends against source routing, so it makes sure that the attacker cannot actually choose the routing path in the network. Basically, with source routing, the attacker can inject in the IP options header of the IP packet what is the path of the network that the devices need to, the packet should take. So for example, if let's say between PCA and the internet, traffic would flow based on network routing, traffic would flow this way via the firewall. The attacker, if the attacker resides on test PCA, the attacker can send that packet with IP options, with source route IP options, which those options can instruct the network devices to route the packet not based on the routing table, but based on what based on how the IP packet tells them to do, which means that devices can end up routing the packet not as the routing table states, but as the IP packet receives states, which means routed this way, which by sending the packet that way towards the internet, the attacker can bypass the firewall. So it can send more traffic towards the internet that otherwise allowed if the traffic was being sent back and forth to the firewall. And we have also IPsec VPNs. We're going to speak about that. How does it help in there as well.